In the frozen vacuum of space, 13 billion light-years from Earth, something impossible stares back at us. The James Webb Space Telescope has peered deeper into the cosmic abyss than any instrument before it, and what it discovered defies every law of physics we thought we understood. Ancient galaxies that shouldn't exist, black holes older than time itself, and phenomena that challenge the very fabric of reality. Something is profoundly wrong with the universe itself. For decades, scientists believed they understood how fast our cosmos was expanding. The measurements seemed consistent, mathematical models aligned with observations, and everything fit together like pieces of an elegant cosmic puzzle. Then James Webb looked deeper than anyone had ever looked before, and the puzzle shattered into 1,000 fragments. The universe is expanding at two completely different speeds, depending on where you measure it. Imagine a balloon being inflated, but the top half stretches twice as fast as the bottom half. This should be impossible. The laws of physics demand that expansion happens uniformly across all of space. Yet Webb confirmed what astronomers feared most. When they measured the expansion rate using distant stars called Cepheid variables, they obtained one number. When they calculated it using the cosmic microwave background radiation, the ancient light from the universe's infancy, they got a completely different number. The discrepancy isn't small or subtle. We're confronting a difference so massive that it suggests our fundamental understanding of reality itself is wrong. Scientists call this the Hubble tension, but that clinical name doesn't capture the true magnitude of what we're facing. This isn't merely a measurement error or a calibration problem. After studying over 1,000 Cepheid stars across 5 separate galaxies, stretching 130 million light-years into space, the contradiction remains stubbornly consistent. The implications stagger the imagination. Either our models of how the universe works are completely broken, or there exists some unknown force tearing reality apart at the seams. Dark energy, that mysterious substance comprising 70% of everything that exists and drives cosmic expansion, might be behaving in ways we never imagined possible. Some regions of space could be expanding faster than others, creating cosmic rifts that challenge everything we know about the geometry of space-time itself. The lead researcher who discovered this crisis put it bluntly: with measurement errors ruled out, what remains is the real and exciting possibility that we have fundamentally misunderstood the universe. The word exciting feels inadequate when you consider what this truly means. If our basic understanding of cosmic expansion is incorrect, then our calculations about the universe's age, size, and ultimate fate are all suspect. Every cosmology textbook would need to be rewritten. Webb's unprecedented precision has removed any doubt about the accuracy of the measurements themselves. Both the newest telescope and its predecessor Hubble are detecting the same impossible contradiction with remarkable consistency. The universe is expanding, but it's doing so in a way that violates the laws of physics as we currently understand them. This discovery alone would be enough to revolutionize cosmology. But Webb was just getting started. As the telescope continued its survey of deep space, it began finding objects that shouldn't exist according to any known theory, behaviors that defy every model of cosmic evolution, and phenomena that suggest our reality is far stranger and more complex than we ever imagined. The expansion crisis was merely the beginning of a cascade of discoveries that would force scientists to question everything they thought they knew about the cosmos. 6 impossible monsters are floating in the ancient cosmos, and they're rewriting the laws of galactic evolution. When James Webb pointed its infrared eyes toward a seemingly empty patch of sky near the Big Dipper constellation, astronomers expected to find tiny baby galaxies stumbling through their first awkward billion years of existence. Instead, they discovered 6 massive, mature star systems that shouldn't have had time to grow so large. These galactic giants contain nearly as many stars as our own Milky Way, yet they formed when the universe was only 3% of its current age. Picture trying to grow a full-sized oak tree in just 3 months. That's essentially what these galaxies accomplished on a cosmic scale. Star formation takes time. Gravity needs millions upon millions of years to pull together enough gas and dust to ignite the nuclear fusion that powers stars. Yet these 6 systems somehow fast-track their development, becoming galactic titans while the universe was still in its cosmic infancy. The discovery happened almost by accident. An astrophysicist examining postage, stamp-sized sections of Webb's deep-field images spotted several fuzzy red dots that looked impossibly bright for their apparent age. Red light in astronomy usually means ancient light, stretched by the universe's expansion during its long journey to Earth. But these objects were both ancient and blindingly luminous, a combination that defied every expectation. Each of these monster galaxies contains between 10 billion and 100 billion stars. To reach such enormous sizes so quickly, they would have needed to form hundreds of new stars every single year for hundreds of millions of years. Our Milky Way, by comparison, creates only about 2 new stars annually. These ancient systems were stellar factories operating at production rates that modern physics says should be impossible. Researchers have informally nicknamed these objects universe breakers because they threaten to break our understanding of how cosmic structures form. According to every simulation and model scientists have created over decades of research, matter in the early universe should have clumped together slowly and methodically. Small structures would gradually merge to form larger ones over billions of years, building complexity through patient accumulation. These 6 galaxies throw that entire carefully constructed timeline out the window. They suggest that the early universe was capable of organization and complexity that cosmologists never imagined possible. Either there exists a completely unknown mechanism for rapid galaxy formation, or our fundamental assumptions about cosmic evolution are catastrophically wrong. The discovery raises profound questions about dark matter's role in early cosmic development. If galaxies could grow this massive this quickly, it means dark matter was clumping together and pulling in regular matter at rates far exceeding current predictions. The invisible scaffolding that shapes our universe might be far more dynamic and unpredictable than we realized. One of the astronomers studying these objects captured the magnitude of the problem perfectly. We looked into the very early universe for the first time and discovered something so unexpected that it creates genuine problems for science. Confirming whether these are truly galaxies or something even stranger requires additional observations with Webb's spectrograph instruments. And what those follow-up studies revealed would prove even more disturbing than anyone anticipated. A monster with the mass of 50 million suns is wandering through space completely alone, and it's rewriting the history of the cosmos. Deep in the early universe, James Webb discovered something that shouldn't exist according to every theory of black hole formation. This object is a supermassive black hole with virtually no galaxy surrounding it. It's essentially naked, drifting through space without the typical host of billions of stars that normally accompany such massive objects. Most supermassive black holes sit at the centers of galaxies like cosmic anchors, surrounded by spinning disks of stars, gas, and dust. They form a symbiotic relationship with their galactic hosts, growing together over billions of years through a delicate dance of gravity and star formation. This cosmic wanderer breaks all those rules. It contains enough mass to equal 50 million of our suns, compressed into a region smaller than our solar system. To put that in perspective, if Earth were the size of a marble, this black hole would still be invisible to the naked eye, while containing more matter than exists in hundreds of billions of normal stars. What makes this discovery truly disturbing is the timing. This object exists in the universe's childhood, just 600 million years after the Big Bang. Traditional black hole formation requires the death of massive stars, which means waiting for the first generation of stars to form, live their brief but brilliant lives, and explode in spectacular supernovas. That process should take far longer than 600 million years. The astrophysicist who helped identify this object described the find as completely off the scale. It challenges every model scientists have created for how supermassive black holes grow and evolve in the early universe. 3 theories attempt to explain its existence, and each one is more unsettling than the last. The first suggests that some black holes form directly from the collapse of massive gas clouds, bypassing the stellar phase entirely. Instead of waiting for stars to form and die, enormous clouds of primordial gas could have collapsed under their own gravity, creating massive black holes in a single catastrophic event. The second proposes that intermediate mass black holes somehow grew at impossible rates by consuming matter faster than physics should allow. There exists a theoretical limit to how quickly black holes can feed, determined by the radiation pressure of superheated matter spiraling inward. These objects would have had to exceed that limit dramatically. The third theory is the most disturbing of all. This black hole might be primordial, created in the universe's first seconds during violent fluctuations in space and time immediately after the Big Bang. If true, it means this cosmic monster has been lurking in the darkness since the very beginning of everything, waiting 13 billion years for stars and galaxies to form and illuminate its presence with their doomed matter. This naked black hole is one of hundreds of similar objects that Webb has identified scattered throughout the early universe. These little red dots appear with disturbing frequency, each one a potential cosmic monster that defies explanation. They glow with the light of matter being shredded and superheated as it spirals inexorably into their gravitational maws. The existence of these naked black holes suggests that the early universe was far more chaotic and violent than cosmologists ever imagined. Instead of the gradual, orderly formation of cosmic structures that our models predict, we might be looking at evidence of primordial catastrophes that forged massive black holes before the first stars even existed. If these really are primordial black holes, they represent something far more ancient and alien than any galaxy or star we can observe. They are relics from a time before time itself had meaning, survivors from an epoch when the universe was so young and violent that our physics can barely describe what was happening. But this naked wanderer wasn't the only impossible black hole that Webb would discover lurking in the cosmic deep. Black holes older than the first stars are lighting up the universe, and they might have been there since the moment of creation itself. Scientists have long assumed that supermassive black holes formed after the first generation of massive stars collapsed in spectacular deaths. This process should take hundreds of millions of years as gravity slowly pulls together enough matter to ignite nuclear fusion. Stars live their brief but brilliant lives, and then explode in supernovas that leave behind stellar corpses. Some of these corpses become black holes, which then grow over billions of years by consuming nearby matter. But James Webb has found evidence of supermassive black holes existing when the universe was barely 400 million years old, far too early for this traditional formation process to work. Researchers have proposed a radical solution to this cosmic puzzle. What if black holes, not stars, were the first significant sources of light in the universe? What if primordial black holes formed in the chaotic first seconds after the Big Bang were already lurking in the darkness when the cosmos was still in its infancy? These hypothetical primordial black holes would have formed through a completely different mechanism than stellar black holes. Instead of collapsing stars, they emerged from extreme density fluctuations in the primordial soup that existed less than 5 seconds after the Big Bang. Picture the early universe as a violently boiling pot of energy and matter, with some regions becoming so dense that they collapse directly into black holes without ever forming stars. The evidence Webb has gathered supports this bizarre scenario. Many of the bright objects in the early universe appear point-like rather than extended, suggesting they're powered by compact sources rather than distributed star formation. When gas approaches a black hole, it heats to scorching temperatures and emits brilliant light. From a distance across cosmic time, this superheated matter can appear almost identical to the light from billions of stars. If this theory is correct, it means primordial black holes were feeding on the universe's first gas clouds, growing larger and more massive while simultaneously lighting up the cosmos with the fierce glow of their consumption. These monsters would have been sitting in the dark for hundreds of millions of years, essentially waiting for the universe to evolve enough to provide them with sustenance. The implications are staggering and deeply unsettling. Primordial black holes could explain how supermassive black holes grew so massive so quickly in the early universe. They had a head start of hundreds of millions of years, allowing them to reach enormous sizes before the first galaxies even began to form around them, like cities growing around ancient monuments. But this scenario raises even more disturbing questions. If primordial black holes were common in the early universe, they might still be out there today, invisible and undetected, drifting through the cosmic void. Some could be wandering through our own galaxy at this very moment, ancient relics from the universe's violent birth that predate every star we can see in the night sky. These primordial monsters represent a fundamental shift in our understanding of cosmic evolution. Instead of a universe that gradually built complexity from simple beginnings, we might be looking at a cosmos that was born with powerful, massive objects already embedded in its structure. The universe's first moments were not gentle or simple, but catastrophically violent, forging objects in seconds that we assume took billions of years to form. The detection of primordial black holes would also provide crucial insights into the physics of the Big Bang itself, revealing conditions in the universe's first moments that we can barely imagine with our current understanding. The energies, densities, and temperatures involved defy comprehension, operating in regimes where our physics equations break down and produce infinities. But Webb's surveys of these ancient black holes revealed an even stranger phenomenon that challenges our understanding of gravity itself and what happens when two massive objects collide at cosmic scales. Two galaxies are crashing together in a cosmic train wreck that's creating physics we've never seen before. When astronomers first spotted the object they nicknamed the Infinity Galaxy, its shape immediately caught their attention. This cosmic oddity displaced two compact red nuclei, each surrounded by glowing rings of gas and stars, creating a perfect figure-8 pattern that resembles the mathematical symbol for infinity. But the galaxy's unusual appearance was just the beginning of its mysteries. The Infinity Galaxy formed when two massive disk galaxies collided head-on in a cosmic crash that began millions of years ago and continues to unfold before our eyes. Galaxy collisions aren't unusual in the universe. They happen with surprising frequency as gravity draws massive star systems together over cosmic timescales. But this particular smash-up has created something unprecedented in astronomical observations. Instead of the typical chaotic merger that destroys both original structures and creates a single elliptical galaxy, these two galaxies have maintained their individual identities while creating something entirely new and baffling. What makes this collision truly bizarre is the location of the supermassive black hole. In normal galaxy mergers, the central black holes from both galaxies eventually spiral toward each other over millions of years, either merging into a single massive object or ejecting one from the system entirely through complex gravitational interactions. The Infinity Galaxy breaks this pattern completely. The supermassive black hole sits directly between the two galactic nuclei, suspended in a vast expanse of glowing hydrogen gas that's been stripped away from both galaxies during their violent collision. This positioning should be gravitationally unstable according to every simulation ever run. The black hole should be pulled toward one nucleus or the other, not floating in the middle like a cosmic referee overseeing the galactic crash. The astronomers who discovered this system believe they're witnessing something called direct collapse black hole formation. Instead of forming from the death of massive stars through the usual stellar evolution process, this black hole might have formed directly from the collapse of a massive gas cloud created during the galaxy collision itself. The process works through a mechanism that sounds almost impossible. When the two galaxies crashed together, they created enormous streams of gas flowing between their cores, like cosmic rivers connecting the two stellar populations. Under exactly the right conditions of temperature, density, and velocity, these gas streams can become so massive and dense that they collapse directly into a black hole without ever forming stars. It's like watching a cosmic avalanche that's so powerful it creates its own gravitational trap, bypassing all the normal stages of stellar birth and death. This direct collapse mechanism could explain one of the most puzzling discoveries Webb has made throughout the early universe. The telescope has found supermassive black holes that are far too massive for their age, growing to enormous sizes faster than traditional formation models allow. If black holes can form directly from collapsing gas clouds during galaxy mergers, they could reach supermassive status much more quickly than previously thought possible. The Infinity Galaxy represents a real-time laboratory for studying this exotic formation process. The black hole appears to be actively feeding on the gas flowing between the two galactic cores, growing larger and more massive as the collision continues to unfold. Radio observations show intense energy emissions from exactly where the black hole should be located, confirming that it's actively consuming matter at prodigious rates. But the most disturbing aspect of the Infinity Galaxy collision isn't what we can see happening now in these frozen moments captured by Webb's instruments. It's what this discovery suggests about the violent processes that shaped the early universe when galaxy collisions were far more common than they are today. If direct collapse black hole formation was a regular occurrence during the cosmos's youth, it means the universe went through a phase of incredible violence and chaos that we're only beginning to understand. And that cosmic violence left behind objects even stranger than wandering black holes and colliding galaxies. It created worlds that should never have existed, drifting through the darkness and broadcasting signals that challenge everything we think we know about planets. Hundreds of orphaned worlds are drifting through space in pairs, and they're broadcasting radio signals that shouldn't exist. James Webb has identified over 500 free-floating planets in the Orion Nebula that don't orbit any star. These cosmic wanderers, each roughly the size of Jupiter, have been ejected from their original solar systems and now drift through the cold emptiness of interstellar space, forever separated from the warmth and light of stellar companionship. What makes them truly bizarre is that many of them travel in pairs, orbiting each other at distances ranging from 25 to 400 times the distance between Earth and the Sunday. Scientists call these paired wanderers Jupiter-mass binary objects. They challenge every theory of planet formation we've painstakingly developed over decades of studying our own solar system and the growing catalog of exoplanets. Planets typically form in the disks of gas and dust surrounding young stars, slowly accumulating material over millions of years until they reach their final size. The gravitational dance required to create binary planets, two worlds orbiting each other without a star, should be incredibly rare if not impossible. Yet Webb has found dozens of these cosmic couples drifting through just one small region of space. The mystery deepened when astronomers pointed radio telescopes at these paired planets and discovered something unprecedented. Several of these binary objects are emitting radio signals with patterns never seen from planets before. These aren't the typical emissions you'd expect from worlds with magnetic fields interacting with charged particles from their parent stars. They're producing gigahertz frequency radio bursts, thousands of times higher in pitch than FM radio signals. On Earth, radio signals at these frequencies come from technological sources or extremely energetic astronomical phenomena like pulsars and quasars. Finding them coming from rogue planets suggests these worlds are experiencing physical processes that don't exist anywhere in our solar system or any planetary system we've studied. The radio emissions appear to be linked to the binary nature of these planets. When two massive objects orbit each other in the isolation of interstellar space, they create complex gravitational interactions that can generate powerful magnetic fields and electrical currents. Think of it as cosmic friction on a scale we've never encountered before. The binary planets are essentially giant electrical generators powered by their orbital dance, converting gravitational energy into electromagnetic radiation. But the signals themselves remain deeply puzzling and somewhat frightening in their implications. Different pairs of binary objects produce different radio signatures, suggesting that each binary system has its own unique electromagnetic personality shaped by subtle differences in their masses, compositions, and orbital parameters. Some emit steady streams of radio waves with remarkable consistency, while others produce sporadic bursts that follow no apparent pattern or periodicity. The implications are unsettling when you consider them fully. If these orphaned worlds can generate radio signals this powerful without any stellar energy input, what else might they be capable of? Their magnetic fields could be orders of magnitude stronger than anything we see in our solar system, creating space weather phenomena that could affect nearby star systems. If any of these rogue worlds passed close to a planetary system like ours, their powerful magnetic fields could potentially disrupt electronic systems or even affect atmospheric chemistry. Even more disturbing is what the existence of so many binary objects suggests about planetary system formation and stability. If hundreds of these paired worlds exist in just one nebula, a tiny fraction of our galaxy's volume, there could be millions or billions of them scattered throughout the Milky Way. Each one represents a failed solar system, a cosmic tragedy where gravitational interactions went catastrophically wrong and ejected planets into the eternal night of interstellar space. These rogue worlds are cosmic orphans, forever separated from the warmth and energy of stellar companionship. They exist in perpetual darkness, their only source of heat coming from the slow radioactive decay of elements in their cores and the tidal forces generated by their orbital dance with their companions. Surface temperatures must be hundreds of degrees below zero, creating environments more hostile than the coldest regions of our solar system. Yet they persist, maintaining their orbital relationships for millions or billions of years, broadcasting their radio signals into the void like lighthouses warning of cosmic dangers. They are monuments to planetary system instability, reminders that the orderly arrangement of planets around stars that we take for granted is actually a delicate configuration that can be disrupted by gravitational perturbations. But as disturbing as these wandering planets are, Webb discovered worlds that challenge our understanding of planetary formation in even more fundamental ways. The next discovery would force scientists to reconsider everything they thought they knew about the basic chemistry of planet formation. A young star system is defying the fundamental rules of planet formation by creating worlds made of the wrong materials. In a star-forming region, James Webb discovered a planet-forming disk that contains almost no water but is rich in carbon dioxide, exactly where Earth-like planets should be forming according to all our models. This finding shatters one of the most fundamental assumptions about how rocky planets develop around young stars. Every model of planetary formation developed over the past several decades assumes that the regions around young stars where rocky planets form should be dominated by water ice, water vapor, and silicate minerals. Water is one of the most abundant molecules in the universe, formed from hydrogen and oxygen, two of the most common elements. Its presence in planetary disks has been considered essential for creating the kinds of worlds that could potentially support life as we know it. The disk around this particular young star throws all of these carefully constructed assumptions into complete chaos. When Webb examined this system using its near-infrared spectrograph, one of its most powerful analytical instruments, astronomers expected to see the familiar signature of water vapor mixed with other common compounds like carbon monoxide and simple organic molecules. Instead, they found a disk where carbon dioxide dominates the inner regions where terrestrial planets typically form. Water is so scarce in this system that it's barely detectable above background noise levels, creating an environment unlike anything scientists have modeled or anticipated in their theories. This discovery challenges everything we understand about planetary formation chemistry. On Earth, water played a crucial role in creating our planet's geology through plate tectonics, its atmosphere through volcanic outgassing, and ultimately the conditions that allowed life to emerge and flourish. A planet forming in this system would develop under completely different chemical conditions, potentially creating types of worlds that have no analog anywhere in our solar system. Two theories attempt to explain this bizarre chemistry, and both have deeply unsettling implications for the prevalence of habitable worlds in the universe. The first suggests that intense ultraviolet radiation from either the young star itself or from massive nearby stars has essentially sterilized the disk, breaking apart water molecules and driving the hydrogen away into space while leaving oxygen behind to combine with carbon. This process would represent a form of chemical warfare operating on planetary scales, with high-energy radiation destroying the building blocks of life before planets even have a chance to form. If ultraviolet sterilization is common around young stars, it means that many potentially habitable worlds might never get the chemical building blocks they need to support life. The galaxy could be filled with dry, carbon dioxide-rich planets that formed under conditions hostile to the kind of chemistry we associate with biology. The second theory is even more disturbing in its implications. The carbon dioxide dominance might result from unusual conditions in the dust grains that make up the planetary disk. Instead of being coated with water ice like dust grains in normal systems, these particles might be covered with carbon dioxide ice due to the specific environmental conditions around this young star, including temperature gradients and radiation fields that favor carbon dioxide over water. If planet formation can produce such dramatically different chemical environments from identical starting materials, there might be entire classes of worlds out there that operate according to geological and atmospheric processes we've never encountered or imagined. The diversity of planetary systems throughout the galaxy might be far greater than we've assumed, with chemistry varying wildly depending on subtle differences in stellar radiation, initial composition, and formation history. This system represents a natural laboratory for studying alternative planetary formation pathways that could never be recreated in any Earth-based laboratory. As the planets in this system continue to develop over millions of years, they'll provide insights into how worlds form when the basic chemical ingredients are fundamentally different from what we see in our own solar system's history. But the strange chemistry of planet formation was just one of many atmospheric mysteries that Webb would uncover as it surveyed star systems throughout our galaxy and beyond. The telescope's next target would reveal a world so hostile and alien that it challenges our definition of what constitutes a planetary atmosphere and what conditions are necessary to maintain one. A world so close to its star that its surface glows like molten metal somehow maintains an atmosphere that defies every law of planetary science. This hell planet orbits its star so closely that it completes a full year in just 18 Earth hours. The entire planet is tidally locked, meaning the same side always faces its star just as the moon always shows Earth the same face, creating a day side hot enough to melt copper and a night side plunged into eternal darkness. Surface temperatures on the day side reach over 4,000 degrees Fahrenheit, hot enough to vaporize most known materials, including many rocks and metals. By every rule of planetary physics developed through studying planets in our own solar system and hundreds of exoplanets, this world should have lost its atmosphere billions of years ago, stripped away by the intense stellar wind and radiation from its nearby sun. James Webb discovered something that should be impossible under these extreme conditions. This hell planet not only has an atmosphere, but it's composed of materials that shouldn't be able to exist as gases at such extreme temperatures, while simultaneously being held down by the planet's gravity. The atmosphere appears to be rich in carbon monoxide and carbon dioxide, creating a thick, gaseous blanket around a world that should be as airless as Mercury. The discovery came through careful temperature measurements using Webb's mid-infrared instrument, which can detect the heat radiating from distant planets. When astronomers measured the thermal emissions from the planet's day side, they found it was significantly cooler than expected based on its proximity to the star. Something was blocking and redistributing the star's heat, and that something could only be an atmosphere thick enough and dynamic enough to transport energy from the scorching day side to the frozen night side. This atmospheric circulation creates one of the most extreme weather systems ever discovered in the universe. Imagine winds howling at thousands of miles per hour, carrying vaporized rock and metal from the day side to the night side, where these materials condense and fall as rain made of liquid minerals and molten stone. The temperature difference between day and night sides should be over 3,000 degrees without an atmosphere. But the thick, gaseous envelope somehow moderates this difference through convection currents that operate under conditions no Earth-based laboratory could possibly replicate. What makes this atmosphere truly impossible, according to conventional planetary science, is its source and persistence. The hell planet's atmosphere can't be a remnant from its formation billions of years ago, because solar winds from its nearby star would have stripped away any primordial gases within millions of years. The radiation pressure alone should be sufficient to blow the atmosphere into space. Instead, researchers believe this is a secondary atmosphere, continuously bubbling up from the planet's interior through volcanic processes operating at unimaginable scales. Picture a world where the crust itself is boiling under the intense heat and tidal forces from the nearby star. The planet is literally cooking from the inside out, causing carbon-rich materials deep in its mantle and core to vaporize and escape through volcanic outgassing. The atmosphere is constantly being destroyed by stellar radiation on one side and constantly being replenished by geological processes on the other, creating a hellish cycle where the planet's own interior feeds its impossible atmosphere. Rock vapor rises from the surface in towering plumes, gets blown around the planet by supersonic winds that would tear apart any spacecraft, condenses on the night side in exotic rainstorms, and falls back down as liquid metal and molten stone. The entire world has become a massive distillation apparatus, operating under conditions that push the boundaries of what physics allows. It's a natural laboratory for studying matter under extreme conditions, showing us what happens to planets when they exist too close to their stars, in environments where the boundary between solid, liquid, and gas becomes blurred. The existence of this hell planet's atmosphere suggests that planets can maintain gaseous envelopes under far more extreme conditions than scientists previously thought possible. This has profound implications for our understanding of potentially habitable worlds throughout the galaxy. If atmospheres can survive in such hellish environments, they might also persist around planets that we've written off as too hostile for any kind of complex atmospheric chemistry, or even the chemistry of life. But the hell planet's impossible atmosphere was just a warm-up for Webb's next discovery, a preview of the cosmic extremes that the telescope would continue to uncover. The telescope was about to encounter a visitor from another star system, an ancient wanderer that would challenge our understanding of time itself and the longevity of objects in the cosmos. An ancient comet from another star system is racing through our solar system, and it's older than Earth, the Sun, and everything we call home. This interstellar visitor appears unremarkable at first glance. Just another icy chunk among the countless comets that populate the cosmos. It's about 7 miles wide, composed of ice and rock like billions of other comets, and follows a trajectory that will take it past our sun before returning to the void between stars. But James Webb's detailed analysis revealed something that shouldn't be possible according to our understanding of stellar system formation and evolution. This interstellar visitor is approximately 7 billion years old, making it 3 billion years older than our entire solar system. When astronomers tracked the comet's steep trajectory through space, using precise measurements of its position and velocity, they realized it came from the Milky Way's thick disk, a region of our galaxy filled with ancient stars that formed when the universe was much younger and more metal-poor than it is today. This cosmic wanderer has been drifting through interstellar space since before our sun was even a glimmer in a stellar nursery, before Earth existed, before any of the planets we call neighbors had formed from the primordial disk of gas and dust that would become our solar system. It predates every geological feature on Earth, every fossil, every mountain range, every ocean. It has been traveling through the darkness of space for longer than our world has existed. Webb's near-infrared spectrograph, one of its most powerful scientific instruments, revealed that the comet's coma, the cloud of gas and dust surrounding its nucleus that appears when it approaches the sun's heat, is dominated by carbon dioxide rather than the water vapor typical of comets from our own solar system's Oort cloud. This unusual composition provides crucial clues about the chemical environment of the star system where it formed billions of years ago when the galaxy was younger and had a different chemical composition. The comet is traveling at over 130,000 miles per hour, fast enough to cross the entire United States in less than 2 minutes. Its trajectory is unusually flat and straight compared to anything else in our solar system, completely unlike the elliptical orbits of native comets. This interstellar intruder follows the gravitational rules of the galaxy rather than our sun, treating our entire solar system as just another obstacle to navigate around on its eternal journey through the cosmos. What makes this ancient visitor truly unsettling is what it represents beyond just being an old object. This comet is a messenger from a time when the universe was radically different from today. 7 billion years ago, when this comet formed in orbit around an alien sun, the Milky Way was more chaotic and violent than it is now. Star formation rates were higher, heavy elements were scarcer in the interstellar medium, and the chemical processes that build planets and comets operated under different conditions. This comet formed around a star that lived its entire life and died billions of years before our sun existed. It somehow survived the death of its parent star, possibly a violent supernova explosion that destroyed its original solar system and sent it wandering through the galaxy alone. For 3 billion years, longer than complex life has existed on Earth, it traveled through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient epoch of galactic history. The fact that we're seeing it now, purely by chance as it passes through our neighborhood, raises disturbing questions about how many other ancient visitors might be passing through our solar system undetected at any given moment. This is only the third confirmed interstellar object ever discovered entering our solar system. But statistical models, based on the detection rates, suggest that dozens or hundreds of these cosmic time travelers should be crossing our neighborhood at any given time, mostly too small or too dark to detect with current technology. Each one represents a fragment of a destroyed world, a piece of cosmic history that survived catastrophes we can barely imagine and traveled distances that dwarf human comprehension. They're archaeological artifacts from stellar systems that existed when the universe was young, carrying information about galactic conditions from epochs that no other objects can provide because they've been traveling through space, essentially unchanged, for billions of years. But this ancient comet also serves as a reminder of our own solar system's ultimate fate and the cosmic recycling that operates on the largest scales. In a few billion years, when our sun begins to die and swells into a red giant before collapsing into a white dwarf, objects from our world might be ejected into interstellar space by the gravitational chaos of the sun's death throes. They'll become ancient wanderers themselves, traveling through the galaxy and potentially visiting alien solar systems billions of years in the future, carrying frozen samples of Earth's ancient chemistry to beings we cannot imagine. The ancient comet's brief visit was a preview of cosmic timescales that dwarf human understanding and our entire civilization's history. But Webb's surveys revealed objects even more mysterious than ancient visitors from dead star systems, objects that challenge our most basic categories of astronomical classification. 300 mysterious objects are glowing in the early universe, and astronomers can't figure out what they are or how they came to exist. James Webb's deep surveys have uncovered a new population of cosmic objects that don't fit into any known category of astronomical phenomena. These little red dots appear as tiny crimson pinpricks of light, scattered throughout images of the early universe like cosmic freckles. But their properties are so unusual and contradictory that scientists are genuinely struggling to classify them. Each one is far brighter than it should be given what we know about galaxy and star formation in the universe's youth. They're breaking the rules in ways that force us to question whether our understanding of early cosmic evolution is fundamentally incomplete. The mystery begins with their color and what it implies about their nature and distance. In astronomy, red light usually indicates either great distance, because the universe's expansion stretches light toward longer wavelengths, or cool temperatures, because cooler objects emit redder light. These objects are definitely distant, existing when the universe was less than 1 billion years old, placing them among the most ancient objects ever observed. But they're also incredibly luminous, producing enormous amounts of energy through unknown processes. They're creating a combination of properties that doesn't match any object in the modern universe, or any theoretical model of what should exist in the early cosmos. Using advanced analysis techniques, astronomers identified 300 of these enigmatic objects in Webb's data from deep field observations. Each one appears to be roughly the size of early galaxies based on their apparent extent, but produces far more light than galaxy formation models predict should be possible at such early times. If they're galaxies, they're unlike any that exist today, or any that our simulations can produce. The objects are so bright that they force scientists to reconsider how galaxies could have formed in the early universe. Traditional models assume that the first galaxies grew slowly, accumulating matter through gravitational collapse over hundreds of millions of years, gradually building their stellar populations through steady star formation. The little red dots suggest that some process was creating massive, luminous structures much more rapidly than current theories allow. But here's where the mystery deepens into genuine confusion. When astronomers try to determine exactly what's producing all this light using spectroscopic analysis, the answers don't make sense and often contradict each other. Some of the objects appear point-like when examined at high resolution, suggesting they might be powered by supermassive black holes rather than distributed star formation across galactic scales. Others show evidence of extended structure in some wavelengths, indicating they might be genuine galaxies undergoing extraordinarily rapid star formation at rates never observed in the modern universe. The most disturbing possibility is that these objects represent a completely unknown phase of cosmic evolution that has no analog in later cosmic history. During the universe's first billion years, physical conditions were drastically different from today in ways we're only beginning to appreciate. Matter was denser on average, dark matter interactions were more frequent because structures were more compact, and the cosmic web of large-scale structure was still forming through initial collapse. Perhaps these extreme conditions allowed for types of object formation that simply can't happen in the modern universe, where conditions are more dilute and settled. The early cosmos might have supported exotic formation mechanisms that operated only during a brief window of cosmic time, creating objects that have no modern counterparts and leave no descendants we can study. Some of the little red dots show evidence of extremely high-energy processes occurring within them. They emit X-rays, ultraviolet radiation, and infrared light in patterns that suggest violent, chaotic energy production rather than the relatively steady output of normal star formation. Whatever is powering these objects is operating under extreme conditions that push the boundaries of known physics, possibly involving interactions between matter, radiation, and gravity that we've never observed elsewhere. The objects also appear to be distributed randomly throughout space, rather than clustered in regions where early galaxy formation was expected to occur based on our understanding of the cosmic web's development. This random distribution suggests they might represent a fundamental property of the early universe, rather than rare, isolated phenomena resulting from special conditions. If they're everywhere in the early cosmos, they're telling us something profound about how the universe operated during its youth. The graduate student leading the research emphasizes that even if only a few of these objects are confirmed through follow-up observations to truly exist in the early universe as they appear, they will force scientists to significantly modify existing theories of galaxy formation and early cosmic evolution. The sheer number of mysterious objects Webb has found suggests that our understanding of cosmic evolution during the universe's youth is fundamentally incomplete, missing entire categories of phenomena and formation mechanisms. The little red dots represent perhaps the most significant challenge to cosmology that Webb has discovered, more so even than the expansion rate discrepancy or the impossible early galaxies. But their mystery pales in comparison to what the telescope found when it looked at the large-scale structure of the universe itself and the patterns that govern the behavior of galaxies across cosmic distances. Galaxies across vast regions of space are spinning in synchronized patterns that suggest the universe might have been born rotating, carrying angular momentum from its very creation. In what may be James Webb's most mind-bending discovery, astronomers have found evidence that galaxies separated by millions of light years, so distant that light takes eons to travel between them, are rotating in coordinated patterns that shouldn't exist according to standard cosmological models. This cosmic choreography defies our understanding of how structure forms in the universe and raises the truly unsettling possibility that the entire cosmos was born with a preferred direction of rotation, with angular momentum built into the fabric of space-time itself from the moment of the Big Bang. The discovery emerged from observations of hundreds of galaxies captured during Webb's deep extragalactic surveys of distant cosmic regions. When astronomers analyzed the orientation and rotation patterns of these distant star systems using careful measurements of their light spectra and morphologies, They found something that should be absolutely impossible according to standard cosmological models, based on the assumption that the universe has no preferred directions. Galaxies that are far too distant to have any gravitational influence on each other, separated by voids of empty space so vast that no force should connect them, are spinning in similar directions with statistical significance that rules out random chance. Think of it like discovering that every windmill across an entire continent is turning in exactly the same direction, even though there's no wind pattern that could coordinate their motion, and they're too far apart to see each. Other. The galaxies are separated by distances so vast that light from one would take millions of years to reach another, meaning that no information or influence could have traveled between them to coordinate their spins. Yet they're all participating in the same cosmic dance, their rotation axes aligned in patterns that suggest some universal coordination.